guys are up and ready for school. No sleeping here. Let's take a look and get going this morning. Looking in Buzz, going to our grade screen as usual. We are finished with the entire first module. The exam was last week. It was due this past Sunday, yesterday. Today, we are starting processing numerical information. So we're going to spend a couple weeks looking at how to do numerical input, and then we'll have our first program and our second program and another program. We got a lot of programs here. But this week, we do not have a program. We're just learning how to do numbers in Buzz. So we'll have some program in the lesson to look at. So you guys can go to the lesson and take a look at that. But let's go to 2.01. I'm going to close this first folder since we're through with that one. And let's open up the second one. All right. Oh, special assignment there. That's just kind of jumping out at me. All right. 2.01, processing numerical information lesson. Let's talk numbers. So in the world of programming, there are a few types. And from now, we're going to focus on two of them. Two types of numbers. Those with decimals and those without. Okay, so that's the two type of numbers we're going to be talking about here in programming. Numbers that have decimals and numbers that do not have a decimal. So try to contain your excitement. I know I'm excited, but using numbers in your code opens a whole new arena of programming. Now we'll be able to do calculations. So that's what we're going to be using this module is numbers and calculating numbers and all kinds of good stuff. So this includes a program, any program that involves points, levels, timing, leaderboards, moves, speed, averages, just anything you use numbers for. Numbers just got a little more exciting. Am I right? Yeah. Yay. After completing this lesson, we're going to know how to identify integers and floating point numbers. Those are decimals. So it has floating point numbers or decimals. Understand how Python can be used to perform math equations. And we're going to learn how to use the string function to concatenate string literals and numeric values. So we're going to add to our knowledge here. Words or numbers? Why pick just one? The world has words. We use them all day, every day. And programmers refer to that as non-numeric data. In programming, words means non-numeric, not numbers. Non-numeric is a string of characters that's a combination of letters, numbers, or symbols and cannot be used in calculations. And yes, we can use numbers in non-numeric data. Like if I call this program 1, we're not going to use that 1 to calculate anything. Program 5, anything like that. So it has number. If it also has numbers, which we call numeric data, programmers work with both. So we have non-numeric and numeric. Numeric is numbers we want to actually do something with. We want to use those. So that's why we'll separate it. So it can have a number in non-numeric data, but we're not going to treat it like a number. So remember Ada Lovelace we talked about at the beginning of the year, the first programmer? She was the daughter of a famous poet, and she became an essayist and a mathematician. And without a doubt, Ada Lovelace was both a number person and a word person. She was both. And actually, so are you. Programmers use numbers in the program code to create your favorite social networks. And those networks thrive on numbers. Instagram, Snapchat, all those things. TikTok. Think about it. Each post includes pictures and words, but numbers are what matter, like the number of likes, the number of comments, the number of follows, the number of shares. Social media is all about numbers. In the world of social networking, numbers almost say as much as words do, right? You see that person that has 3 million followers. That says something to you. You're like, oh, wow, okay, I need to be following this. In the world of programming, numbers and words both have important jobs as well. So life would be different today if we'd never figured out numbers, like no internet, different, no buildings, no agriculture, no medicine. Think about it. Lack of Wi-Fi would be the least of our worries if we didn't ever discover numbers. Of course, sometimes numbers get pretty complicated, which is why we have calculators that we use now and computer programs. So Python has a great ability to help us crunch numbers so we can stay out of the dark ages. Look at page 3. We'll get to some examples here. All right, these are the two type of numbers we want to talk about. Integer. I'm the whole package. We know what an integer is. It's -2, it's 0, it's 5, it's 11. It's all the numbers we know, including negative. Those are integers. Float means always have a point. That means it's 2.1. It's 1.95. It's negative 13.6. Anything that has a decimal is a float number. We have integer and we have float. That's the thing we need to know how to do. So the first thing to learn now is how Python categorizes numbers, integers and float. So you're using a high-level programming language to say something the computer can understand. That means you got to use specific terms so Python knows what you're talking about. So there are actually two different numerical types, and Python looks at them differently. So int is our integer command. It refers to integers. They're all positive and negative numbers and 0. Let's look at an example. Negative 12, 4, 0, 234, negative 768, 9. Those are all integers. You recognize that because you've had math for years and years. Float refers to floating point numbers. That's anything that contains a decimal point. All of these are floating. 0.0. That is a float number in programming because it has the point 0. 4.64, negative 234.145, anything that has a decimal in it. So why does this matter? Excellent question. I'm glad you asked. There's actually 3 reasons why this matters when you're working with Python. Memory. Memory has always been a huge thing for programmers because for the longest time, memory's gotten a lot cheaper now. But, like memory would be expensive. Just getting 4 megabytes. I'm not talking about gigabytes. I'm talking about 4 megabytes when programming started back, let's say 30 years ago in the 90s. 4 megabytes could cost you $100 just for a little bit of memory. Now you can get a hard drive that's 4 terabytes, which is like huge compared to 4 megabytes. 4 megabytes, 4 terabytes won't fit in the room. And you can get that for under $100. It's crazy. Memory's a lot cheaper, but the more memory you use up with your program, the slower your computer runs. So you may be working with a program that tends to take up a lot of storage space on your computer already. And floating point numbers take up more space than integers because it's got to save that decimal value. So if you can use a 1 instead of a 1.0, you save yourself some memory. So it makes a difference. If you can make it an integer rather than a float, you can save memory. Precision. You may need to have a specific number that requires decimals. Maybe you need to be more exact than just an integer. So floating point numbers allow for more precision. If you're using 7.5, that's more specific than 7, right? And arithmetic, you may need to have the correct math. So the results of integer math and floating point math are not always the same, right? Because 11 divided by 5, Python will say it's 2. But if you need it to be more accurate and use decimals instead of integers, you'll find that's actually 2.2. So using an integer rather than a float could affect your accuracy. All right, page 4. So Python, the calculator. In Python, we often assign values to variables, right? These values can be numeric or alphanumeric. And the good thing is we don't have to tell Python which we're using. It'll tell by itself what we're using. So let's say you want to create a Python program to help with your math. You might start with something like this. X equals 5, right? That looks common in algebra class. You can see X equals 5. In Python, the equal sign means something different. You use that to assign a value to a variable. X equals 5. That means we've taken X and we've assigned the value 5 to X equals X plus 1. We've taken X and we've assigned X plus 1. And when you print X, Python can handle that. It knows from your code you originally assigned 5 to the variable X. And then it knows you took that value and you added 1 to it. So when you print this, you'll get the number 6 on the screen. You're like, okay, well, that makes sense because that's how that would work in algebra as well. If we said X equals 5 and then we said X equals X plus 1 and we knew X was 5, we knew it should equal 6. So Python understands how to do that. It also understands using an asterisk to multiply, a slash to divide, and more. So let's look at this. Python will follow the order of operations. So you got to make sure you do things using parentheses, exponents when needed, anything like that. So be aware of this when you put equations in. So let's do some practice here. This is where you go into Buzz, go to page 4, and practice with the numbers, especially before you write the program. You should go to page 4 of your Buzz lesson and do some practice with this. Look at these directions over here on the right. Read the code, try to predict the output. All right, let's look at this, see what we think. There's our main function. All right, let's see. Hashtag assign integer value. So that's just a comment. Python does nothing with that. It skips that line. We have x equals 5. So we've created a variable and we've named it x, and we've assigned a value to it, the value of 11. Then we created another variable. We called it y, and we assigned the value 5. Then we have 4 print statements. Print x plus y, x minus y, x times y, and x divided by y. And we put a comment in there too. Just let us know what this is. Printing arithmetic results. So let's run this and see what it does. 16, 6, 55, and 2. These are integer values than when they were assigned. So it's printing the output as integers. There's no decimals. So it says, okay, these are integer values. 11 plus 5 is 16. 11 minus 5 is 6. 11 times 5 is 55. And there's that 11 divided by 5 is just 2. So when arithmetic is performed with integers, it'll always give you an integer answer. So we know 11 divided by 5 is not exactly 2, but Python didn't have an option because it says we're just using integers. I can't give you any other number. Let's look at the next one. Now let's see what's happened. Oh, so now we've changed the values. I'm going to scoot that down a bit there. Now we've said A is 20.0. So we said, okay, it's 20, but I don't want the integer 20. I want the floating point 20, which means you can use decimals in your answer. And 2.5 will be B. So we got A and B, and we've assigned them both to be decimals, floating point numbers. And we're doing the same thing below. Run program. So 20 plus 2.5 is 22.5. 20 minus 2.5, 17.5. 20 times 2.5 is 50.0. It's going to give you that floating point 0 because it's using float. And then 20 divided by 2.5 is 8.0. So we always get a floating point answer, even if it's an integer. Because really, 20 times 2.5 is an integer, that's 50. But since we're working with float, it's always going to present it as a float, unless we tell it not to. So, all right, let's take a look at the third example. Mixing integers and floats. All right, this is what we want to know what happens here. So we've assigned the count to be 10 as an integer. We've assigned the cost to be 8.99. So we're buying 10 items that cost $8.99 each. And we said, let's calculate the total cost. All right. So we said total cost of our purchase, 10 times $8.99. Count times cost. And down here, print the results. Print the words total cost, because that's in quotes. So it's literally going to print exactly what's in the quotes. And then print whatever we calculated above up here, total cost. All right, let's run this, see what it looks like using the integer 10 and the 8.99 float number. Notice the output. When we mix them together, it says, well, I'm going to have to use a float value because I don't know what the decimal does to the calculation. So if we multiply an integer times a float, we're going to get a float. Integer times a decimal will give you a decimal, 89.9, which is the exact answer, right? 10 of those should be 89.9 and gives us the exact floating point number. All right, let's look at example 4. Here's where order of operation plays in here a little bit. All right, so we're going to have number 1 equals 85, number 2 equals 95, and number 3 equals 91. And we're going to calculate the average. So kind of get an idea in your head, what should the average be about what should the average be between 85, 95, and 91? Right? So that's when you add them all together and divide by 3. So you take number 1, number 2, number 3, add them all together and divide by 3. And we made it a floating point because it may not be an exact integer. And then we're going to print the average is and whatever that calculates because we're calculating the average. Here you go. Let's run it. The average is 210.33333. What do you think? Does that look right? Does your number sense say, yeah, that's about the average of those 3 numbers? What do you think? Yes? No? No, I'm seeing some head shaking. No, that's not the average. If you had took 3 tests and you scored an 85 and a 95 and a 91, your grade in the class would not be 210. Something is wrong here. Seriously. Now, we wish that's kind of how that worked. Okay, yeah, my grade's 210. I'm doing great. But we know that's not right. So something went wrong. The average is incorrect. So we got to fix that because order of operations. Order of operations says before you add, you have to divide. So the first thing it did is it took number 3 and it divided it by 3. Then it added everything together because addition comes after division. So that's the problem. It took 91, it divided it and got 30.3333 and then added all that together. Well, if we want it to add everything up first, we have to put parentheses around that. Before you divide by 3, add these 3 numbers together. Order of operations says parentheses comes before division. So if we make it add everything up first, then divide by 3, this should be a number closer to what you're expecting. So let's run it again. 90.33. Okay, that looks about right because in our heads, we said it's got to be somewhere between 85 and 95 because that's all the numbers are between 85 and 95. So it can't be a number outside of that range if it's the average. So that looks correct, 90.33. So remember, you have to force it to do order of operations in the way you need it to do. And we had it wrong because we let it do the division first because that is proper order of operations, but that's not what we intended. We intended it to add those 3 numbers. So use parentheses because that's first in the order of operations. All right, let's go to slide 5. Changing a variable's value. Okay, so here's our main function. Let's scroll down where we can see more of what's going on. Okay, there's our whole function. X equals 5. Okay, so the first thing we did is we assigned a value and we're going to print it. The value of X is, and we're going to print what that is. Then we have this calculation that says X will now be whatever X was plus add 1 to it. And then we're going to print that. The new value of X is whatever it is then. So we've kept the same name. We're just going to change the value of it during our program. So let's run this. The value of X is 5. The new value of X is 6. Perfect. That's exactly what we expected. We assigned it a value of 5, and then we said, whatever it was, add 1 to it. All right, now look at this up here. It says, can I add a +1? It says, make changes to the code so that the value of X is increased by 10 instead of 1. Okay, well, that should be simple. Instead of adding 1 to it, let's add 10. X plus 10. So now we expect it should print a value of 5. Then it should add 10 to that same value and print the new value. Run. There we go. The value of X is 5. The new value is 15. Perfect. All right, they have one more example here. Calculate the total cost of a meal. Define main. The entree, we have not put a value there. The drink, we've not put a value there. Tip, not put a value there. So calculate. So this calculates the meal cost of an entree and drink. So meal cost, I guess we're going to put these calculations there. And then if you add a tip, total cost. So then they print it. Total cost of meal will be whatever we calculate. So let's see what they want us to do. Write a program to calculate the total cost of a meal, including an entree, a drink, and a tip. And let's assign a value to the entree, the drink, and tip. And we'll say if the tip is 18%, you should put 0.18. Yeah, because that is 18% as a decimal. And then we have to write the calculation for the total meal cost and total cost. All right, so let's see. The entree and the drink. Are we going to be at a nice place and get an expensive entree? Or are we going to be getting like fast food, cheap stuff? Let's make it kind of nice. Let's say we're going to go to a steakhouse or Olive Garden or somewhere, and we're going to get a nice entree for let's say like $17.99, right? Because nothing costs like $17 or $18. It's always $17.99. So in your mind, you're thinking, oh, $17, that's cheaper than 18. Is it really? It's really not. It's a penny. So $18 is what our entree costs. And drinks are really high now. They charge like $2.75, which is more than, like that's how much you can buy like a 2-liter for, but they serve you that for a glass of tea. So there's the entree and the drink. And the tip will be, let's see, what percent? 18% is fine. So we would say the tip will be, do we want to calculate the tip here or do we want to calculate it later? We can calculate the tip here. So let's do that. So the tip would be adding the entree and the drink together and then multiplying it times the 18%. So we would say, okay, whatever the entree costs plus what the drink costs. And then we're going to multiply that. That little asterisk button is the multiply. And we're going to multiply it by 0.18. Give an 18% tip. Nah, let's see. The service wasn't that good. We're going to make it 15% just to play. Okay, I'll be nice. 18%. But notice with you the parentheses. If we don't use the parentheses, it'll only tip the drink because it'll do the multiplication first. So the parentheses forces it to first add these two together and then give the tip. All right, so calculate the meal cost. The meal cost is just the entree plus the drink. And you're thinking, well, why do I have to do that? Can't I just do $17.99 plus 2.75? You can, but what if I change my order? Then I'm going to change these numbers twice. If I change the order, if I've got it saved in a variable, I should use that variable. So if that number ever changes, I don't have to redo this. I can forget about this. So add the entree. Oh, that's not a plus. And the drink. So we'll just add them together there. That's the meal cost. And then calculate the meal cost with the tip. Okay, well, it's whatever the meal cost is plus the tip because we've calculated the tip right there. We could have calculated the tip down here. Meal cost plus the meal cost times 0.018. We'll look at that in a second. Make sure it comes up the same. Okay, entree, drink, tip. Entree and drink. Total entree, drink, and tip. Let's see what it comes out to here. Name error, meal cost is not defined. Oh, because I didn't capitalize it. See, that's a different word. This is meal cost. In camel case, I did not put the capital C, so it says that's a totally different variable. I don't even know what you're using. I have to make it exactly the same. Meal cost, meal cost. All right, let's try it again. 24 and 47 cents. 32 would round down. Great. We don't have the knowledge at this time to make that look like, 2 decimals. I mean, we could put a $sign in front of it inside the quote. And when we run it then, it puts it in the wrong line. We'd have to concatenate down here. We could concatenate a $sign, but that's going to create another problem because now I'm kind of jumping ahead. This is not a number. This is a number. Look what happens. It says, I can't put letters and numbers together in the same print statement. Whoa, that's why we did that on 2 lines and didn't put this all on 1 line. Python says, I can't do numbers and letters when I'm printing. I have to do either numbers or letters. We can fix that. Let's see. Do we have that on page 5? I think page 5. Yes, page 5 will help us fix that. Okay. Eventually, you're going to find yourself printing a zillion different statements. It gets confusing and makes your code look long and messy, especially if we have to do it on separate lines. The cost of your meal is, and then the numbers on another line. And then this is, and the numbers on another line. So the problem is Python will not let you put string literals and numeric values together. We just saw that. Well, they got another built-in function we can use called str string parentheses. So let's say we want it to print score 1337. Your epic score is, and we want to put it on the same line. We don't want two different lines. And then put a period after it. So we'll get an error when we do that. We just saw that in the last program we were playing with. You're trying to concatenate a string literal, which is numbers and letters and characters that are not being used as numbers, and the numeric value 1337. Well, there's a way we can do this. We can make it say your epic score is 1337. If we put the number, and score is the number, inside the parentheses with an str in front of it, that tells Python, look, I know this is a number, but I want you to act like it's not. Act like it's a string literal. So you can print all the string literals together. I know it's a number, it's not a string literal, but please, just for the purpose of the print statement, would you act like it's a string literal and print it, please? So string, integers, and floats, these are basic Python data types. And if we use this string in front of it, it'll treat it like a string. Let's take a look at a practice activity for this. So here's back to this same type of program that was calculating averages, 85, 95, 91. This time we did it differently, so it worked right. We didn't have to use parentheses. We added up the total points on one line. All right, add those three together, and then took the average on another line. We said, whatever that adds together, divide it by 3. Now that fixed the problem too. We just had to use 2 lines instead of putting parentheses around the numbers. And then we said, print your stats, print a blank line. That just prints a blank line if you want to separate things. Total points, average points, main. All right, run this. Here's your stats. Your total points, 271. Average, 90.3. 3. A lot of 3s. So let's see. We'll go to the next slide. We said, okay, let's try to put this together. Total points on the same line. Total points plus total points. When we run that, we get that same error we had just a minute ago. String and integer, you can't do a string literal and numbers. But if we use this new command we just learned and put it in parentheses, we've got to put another parentheses because we've got to have parentheses for this one and then parentheses for the whole print statement. Right. So now I said, okay, this is a string literal and I know this is a number, but please act like it's a string literal and print it for me. Let's see how that does. Oh, looky there. Total points 271. We printed our number on the same line as a string literal because we told Python, wink, wink, this is a string literal too. Right? Please act like it is. And it did. Nice. Now we just need to move average points up here. Let's see, is that the third slide? Use the string function and concatenate. Combine the statements for printing the average into one. So now it wants us to do the same thing here. All right, so let's take concatenation, string, and put average right here. And we don't need this second line now. All right, so total points of print on one line, average points of print on the next line with the words average points in front of it. Run. Oh, that looks so much neater than having to put everything on its own line. Numbers on one line, string literals on another line. So this is a handy function that we're going to use in our next program going forward. So come to page 4 and page 5 and play with it. Practice it. Try writing your own calculations. Try adding your own stuff in there and see if you can make this work properly. But see if you can print things on the same line, headings for what this number is. What is that number? Oh, it's the average points. I told it right there. So when you got the printout, you can see what it is. Total points, average points. So processing numbers is something we're adding to our knowledge in Python programming. You've got 5 pages to play with it there, talk about. It says, okay, now just do the quiz that goes with this. So let's look at the assignment. In programming, what is an integer? Okay, we can get that. That's a good start. Read the code. X equals current age, print X plus 20. What will this calculate? Parentheses are used in calculations where order operations affects the outcome. Christina used the following expression to calculate the average over 3 program users. The average age 1, age 2, age 3 divided by 3. This is not correct. How should you fix it? And here's some code. How can the average be corrected in order to return the correct output? Because this is giving the wrong number. That's it. 5 questions. I think next week is also a quiz. I think we get 2 weeks. I'm pretty sure the next 2 weeks are just 5-question quizzes, which means if you're behind anything from Unit 1, this is a chance to get your programs written, turned in before we start adding new programs onto you this time, because we're about to have some more programs. Those programs are worth 100 points each. So if you haven't got those turned in, it's affecting your score big time. And the more 100-point programs we have, the more it affects your score. So make sure and get any missing programs turned in. Then there's a few. There's not a whole lot. Most of you have everything turned in. Good job. But there's a few people that are still missing some things. So this is your chance. This week and next week, when we have very short assignments, it's your chance to get caught up. If you're having trouble writing your program, email it to me. Say, I'm getting an error on line 11. I can't figure it out. Copy. Don't send me a screenshot because I can't run it. I can't run a screenshot. I won't be able to see what your error is. But if you copy it and paste it to an email, I can copy it and paste it into an idle window and run the program and see the error myself. So, but I am happy to help you find errors if you cannot figure them out. Give it a shot first, though. The better you get it, debugging it, the easier programs get, because you'll figure out your own mistakes and not make those mistakes going forward. Oh, yeah, I got to do this or I'm going to have an error. So email me if you have trouble with that. Come to class. Oh, wait, this is not an A today. Back to my last year, A's and B's. I got tired of not being able to see the A up there. This is the B day Friday. So we will have class Wednesday only. So if you need help with your program, you can come Wednesday and say, Mr. Brock, help me. Or you can come to virtual lab if you want to sit in the room behind this wall and work on your program, anything like that. So, all right, guys, that's it for this week. Short 5-question quiz. So if you're current and caught up, you got an easy week. If not, let's get caught up. We'll see you guys next time. Have a fabulous week. Bye.